Hello everyone, Mr. Hine, and today we're going to be comparing exponential growth versus linear growth, because in the last video we explored, or in the last lesson we explored what exponential growth is, and hopefully what you remember from last video is that linear growth was anything that grows by addition and subtraction. Remember, the addition and subtraction go hand in hand, because if it's a minus you could just add a negative. And exponential growth, which is by multiplication, which multiplication is the same as division, just multiplying by a fraction. For example, dividing by 2 is the same as multiplying by 1/2. So let's compare these two and understand that. So I'm going to look at two cases here, different than your work, because I don't want to take that away from you, but hopefully help you see the main idea here. So example 1 is, let's say we start with 500 rabbits and they gain 50 more each month. So I'll go month, number of rabbits, and we'll make a table of this to compare it. And we'll look at this case over here where we start with 2 rabbits and each pair will have 6 babies per month. Okay. So here we go. In this first case here, you start with 500. So in the very beginning, there's 500 rabbits and gain 50 more each month. So that just means that we are adding 50 each month. And I can keep doing this, and I'm going to go down to 5 and see what happens. So 3, 4, 5, that's 600, 650, 700, 750. You keep adding 50. Okay. So notice that it's adding, and hopefully what you're thinking to yourself is, well, then that means that this is the linear growth because of the plus 50. Okay. And if we want to go a step farther before we look at the other case, the equation here is going to be y equals the starting value, which is 500, plus 50x, where plus 50 is your pattern, right? So your start and your pattern. Okay. Now let's look at this case over here. Is in the beginning there was only 2 rabbits, so we have in month 0 there was 2 rabbits, and each pair had 6 babies per month. Now, so just be careful here. So let's draw a picture here. So you have 2 rabbits, and that pair has 6. 1, 2, 3, 4, 5, 6. So in total, after 1 month, there'll be 1, 2, 3, 4, 5, 6, 7, and 8 rabbits. Sorry about my dog. All right. And then if we went to a second month, maybe you're not sure of the pattern, that means that each pair, so now if I use a different color, has 6 babies. So that original pair is going to have 6 more. This pair will have 1, 2, 3, 4, 5, 6 more. This pair will have 1, 2, 3, 4, 5, 6 more. This pair will have 1, 2, 3, 4, 5, 6 more. And if you add all that up, I know it's a lot of counting, but you have the 8 previously, and then you have another 6, which would be 8 plus 6 is 14, plus another 6 is 20, plus another 6 is 26, plus another 6 is 32. And if you notice here, the pattern here is it's actually timesing by 4. And the way you can see that visually is when I said one pair had 6, we'll notice that that original grouping of 2 quadruples in size. It goes from 1 group of 2 to 4 groups of 2. Sorry, you didn't see that. So it quadruples in size. So we can keep timesing by 4 here, and I'm going to go out to the 5th month as well. And I'll put these in my calculator that I have right next to me. And you would have 832, and then you'd have 128, 512, and then 2048. And this, because of the multiplying, is exponential growth. Because of the timesing by 4. And what's the equation here is it follows the same as the linear, where what's their starting value? 2. And what's the pattern? Well, instead of plus 50, the pattern was times 4. So it's times 4. But we wouldn't put times 4x, because when you keep multiplying, you don't say it's times 4x. We say it's to the x power. Because like 4 times 4 times 4 is 4 to the 3rd, not 4 times 3. And that's why we do powers. Okay. So here we go. Let's look at the graph and see, did you just understand what just happened? Something big just happened. Did you see it? So we have months, rabbits, and I will do linear in pencil, and I'll do exponential in red pen, so we can compare the two. And you see here that with linear, it starts at a number 500, and it's going to add 50. And it might look something like this as a sketch. This is a sketch. Where after the 5th month, it was at 750. So after 1, 2, 3, 4, 5, it was roughly at 750. So okay, that's a lot of rabbits. Sorry, there you go. But look what happens at the exponential one. The exponential one, we started with just 2 rabbits, and then we had 8. So that means in the beginning we're way down here, we're way down here, and then it went up a little bit, and then it went up even higher, and even higher. But at the 5th month, notice at the 5th month, so before the first 4 months, linear was higher, it was at 500 compared to 2, 550 compared to 8, 600 compared to 32, 650 compared to 128, 700 compared to 512. The linear was higher, and it stayed higher, and you can see on a graph that the line is higher than the exponential. But notice on the 5th month, this is at 750. This one shoots up to 2048. So the graph, notice what's going to happen on a graph is it's going to look something like this. It's lower, it starts slow, and then it starts accelerating, and accelerates so much where it's way up here. So you can see that exponential, as a reminder, it starts slow, but it can accelerate very quickly. And that's the big idea there. And you might be saying, oh man, and say this was money, because this is, money is something that these numbers will make sense of. Well, you might say, okay, I like this pattern. I get to start with a lot of money. And that's great. Starting with a lot of money is a good thing. But notice here, if you understand that it's not about the starting value, if it's exponential, this is going to grow by a lot. You can see that rate, as much as it's going slow in the beginning, only adding 6, adding 24, adding roughly 90, adding roughly 400, it starts slow, but then it starts adding thousands, and it just piles so quickly. With numbers, that's when things can get out of control. Right. So there it is, linear versus exponential, knowing that exponential starts slow, but it can accelerate very quickly, while linear just kind of stays the same the whole time. Hope that helps you with your case. Hopefully it helps you make sense of it yourself as you do the worksheet. All right, good luck.